With all the crazy goings on in the world, sometimes it's easy to overlook the advances that AI has been making in the past year to 2 years, but it's really worth a look. What's going on at the cutting edge of research right now is so mind-blowing, it's actually hard to wrap your head around, and a lot of researchers in the area are saying this, and the effect this could have on everyone's daily lives could be immense. Let's take a look. And for those of you interested in investing, check out WeBull, an amazing platform for buying and selling stocks, and now cryptocurrencies like Bitcoin, Dogecoin, and others. Open an account and get a free stock valued at up to $200, and fund your account and get another free stock valued at up to $1,600. Check out the link in the description and help the channel at the same time. Hey y'all, it's Dr. Know-It-All. I've been thinking about this episode for weeks now, and I've had a hard time even wrapping my brain around how to go about doing this episode. So I think the way I'm going to construct this is a sort of a conversation. So consider this like the first sentence of a conversation, and then I'm going to wait for all of you to give me a second sentence, to reply to me, and then we'll continue this conversation back and forth. So please, by all means, let me know in the comments what you think. And of course, if you're a Patreon patron, you can contact me directly on Patreon or on Discord. So that might be a more direct route for this. But anyway, I definitely want to consider this a conversation starter. So think about it that way. I'm certainly not going to try to be complete about this. There's a ton of other videos out there about this kind of thing. There's papers. There's so many papers. I can't keep up with reading the papers. Even the abstracts, I'm like, oh my gosh, I can't keep up with all these things. So there are literally like, thousands of papers that are out right now about this, and things are moving forward at a clip that even a couple of years ago would have been hard to imagine. So I'm going to give a very, very brief historical kind of overview, then talk about the major large language models or large models. I don't know what to call them anymore. They used to be large language models, but now they're kind of expanded beyond that. But anyway, large models that are out there for AI and machine learning. And then I'm going to talk about the effect that this can have on society at large, including Tesla and full self-driving and so forth. That's fairly obvious. But I think there are other things like video thumbnails and stuff. I have a friend who's got Dall-E 2 access, and I gave him a prompt. I'm hoping he's going to feed the prompt into Dall-E 2, and I'll actually get a thumbnail generated out of that. So hopefully what you'll see for the thumbnail for this video will actually be based on a prompt that I gave him. If that's the case, that'll be really, really cool. That would be one thing I would be happy to turn over to an AI. I'd love to let it generate the thumbnails. It causes me a lot of stress thinking about that. So anyway, there's this massive range of potential for these large models, but let me start with just a little bit of history, and it's not very long. All right, so if we go back to the dawn of AI back in the 50s and the 60s, we had things like neural nets and perceptrons that were conceptualized and built in rudimentary fashion back then. The real sort of, and I'm skipping forward, gigantic 50 years, etc. But anyway, the real breakthrough came in 2012 with AlexNet destroying the ImageNet competition versus all of these other hard-coded machine learning methodologies. So this is 10 years ago. We're talking about 1 decade since neural networks came to the forefront and became the really big thing. What's even more scary is the beginning of this last push has only happened in the last 5 years. If you go back to almost exactly 5 years ago, June of 2017, Attention is All You Need was the paper that sort of introduced transformers to the world. So that was almost exactly 5 years ago from when I'm recording this. And without going too deeply into this, transformers are a different type of architecture that machine learning can use. It's related to things like RNNs and LSTMs, but basically the idea is that it has attention, which is why the paper was titled that, obviously with a riff on the Beatles song, Love Is All You Need. But basically the idea is that it can pay attention to things. One of the problems with previous models, if you take a long sentence with like 10 words in it or something, the model doesn't really have an idea of what the important things are. It used to create what was called bag of words, which if you've heard Elon Musk talk about bag of points before, and by the way, I've done episodes on this if you're interested, but he talks about bag of points. Bag of points is sort of a spatial relative of bag of words. So it doesn't have any real idea of what's important in this. So transformers, the sort of key thing about transformers is that they pay attention. They actually care about what's important in a sentence. And the idea for these things is that they can generate things. When I talk about GPT, it's generative pre-trained. A transformer, it's a transformer and it generates. So what it does is it looks at the words and then it builds the next word and the next word and the next word. That's how these things work. So anyway, the idea crystallized in a paper just about exactly 5 years ago. Then about, I guess it was less than 2 years ago, October of 2021, an image is worth 16 by 16 words, which is, you know, an image is worth 1,000 words, right? Ha ha ha. So anyway, that's 256, by the way, 16 times 16. I had to actually calculate that in my head before I recorded this because I was like, is that actually 1,000? But anyway, the idea is that then you can take this generative pre-trained idea, you can take this language model and you can actually transfer it to spatial models. And then people have actually done it with video sequences and things like that. Andrej Karpathy with Tesla has specifically talked about how Tesla AI is using GPT-like things in their full self-driving. And so obviously they would be using spatial versions of things because it doesn't really care about words, it cares about space and probably video sequences. But the basic idea here is that they're using images and video sequences and they're paying attention to specific parts of those sequences to really understand the world around them. It's very, very cool how all of this stuff is working and how something that was originally designed as a language model is actually growing out to become something that can be used spatially. And now it's being used in really interesting ways and much more creative ways. And that's the part that's really fascinating to me. All right, so now let's look at state of the art. This has nothing to do with Tesla in particular, but basically the competitors are Google and DeepMind and OpenAI. So I'm sure you've heard of OpenAI and GPT-2 and GPT-3 before. Those two models are kind of the originating models. There was a GPT, but it was more like a small scale, I guess, test bed sort of thing. GPT-2 was the first one that really came out and said, look what a large language model can do. And what do I mean by large? I actually mean the number of parameters involved. So I'm going to go through sort of a list of all of the different competitors from the different companies that are out right now and the number of parameters that they have, as far as I can tell at least, and just some basic statistics about what each of these different models is. All right, starting with OpenAI, of course, like I said, we have GPT-2, which has 1.5 billion parameters. And the number of parameters is the really, really big thing here. When you start going to hundreds of millions of parameters, to billions of parameters, to hundreds of billions of parameters, to eventually trillions of parameters, that's what we're talking about. These models are getting bigger and bigger and bigger. And it's really amazing that the compute power that we have now and the data that we can feed all of these things is adequate to train these things and to make them actually operational. But that's the basic idea here. When I talk about large models, what I'm talking about is over a billion, or actually a lot of people probably say over 10 billion parameters or something like that. These are really, really big. Again, you can think about parameters as sort of like tuning knobs on a mixing board for audio. Each one of those knobs, so imagine having a billion of those little knobs that you can adjust to change the audio from the input to the output, and how different everything could sound from, you know, somebody singing without reverb and all of this stuff. You know, this is a real basic analogy, but right, you can turn on the reverb effect and you can turn up the amount for different frequencies of the sound or something like that. So I don't know if this analogy helps. I happen to be a music person, so it helps me out to think about it that way. If you're not a music person, it might just make it more confusing. But anyway, the basic idea is that you have all of these little knobs that you can tune, and all of those knobs take the input, they mess around with it, and then you get an output. And so that's the basic idea of pretty much any machine learning model using neural networks. So anyway, GPT-2 had 1.5 billion parameters. GPT-3 has 175 billion parameters, or about 100 times, or about 2 orders of magnitude more parameters than GPT-2 did. What's really scary is that OpenAI is already talking about GPT-4, and they're saying it's going to have 100 trillion parameters. That's not billion, that's trillion. So that's another 2 orders of magnitude bigger than GPT-3. So we're talking about just insane amounts of parameters. It's really incredible to think about this kind of thing. And just as a point of reference, GPT-3 costs about $5 million to do the pre-training part. Remember, that's generative, so it generates things. pre-trained transformer. The pre-trained part means that they take this and they train it on, in this case, again, it's a language model, so they train it on massive amounts of language, which is, hey, we've got the internet. So you can scrape all of this data. Again, something you could never do before very recently, but you can scrape language and language and language. And if you're doing like just an English only one, right, you can take only English ones, but you can also do Chinese or Arabic or whatever languages you want. You put all of this stuff in here and you pre-train this thing. And then what you can do, which you can take that pre-trained thing and you can sort of fine tune it. You can overfit it to particular tasks, which is very, very useful. And that's what these models are useful at. But the pre-training part is very expensive and takes a very long time on a lot of computing power. So GPT 1 through 4 are all pretty much language-based models. So they're designed to, if you give it any kind of prompt or something, it then goes through and it replies and it says things that make sense. And if you've been watching the news about the Google researcher who says his AI is cognizant or conscious, that's kind of along the lines of all of this stuff. It's a language-based model. It's very flexible. It's designed to produce very realistic results. So in my mind, we're not talking about something that's actually conscious at this point. Of course, I don't know the details. Maybe he's right, but I don't think so. At least from the outside, it doesn't appear this way. But we're getting to things that are impressively creative in language. But we can also do this with images, and that's what gets really cool in the latest renditions of this. So basically, we're taking the GPT kind of idea and we're expanding that to visual images. So imagine, instead of just ingesting language, ingest language and images. And the idea is to put these together. So you have, like, you know, a person playing a guitar, that's the label, and then you have a person playing the guitar. And you can pre-train these things to understand what all that is. Then you can ask these models, you can say, show me a picture of a tiger playing a guitar. And it can blend this stuff together in a creative way. And instead of showing Elvis Presley playing a guitar, it can show a tiger playing a guitar. Now, it's not doing like Photoshop, right? It's not taking a picture of a tiger and pasting it on top of Elvis Presley. That is not what it's doing. It's creating this stuff from scratch, which is really, really amazing. But this is the state of the art. This is the thing that really, really started with Dall-E from OpenAI. And if anybody's interested in the technical details, Dall-E was autoregressive, while Dall-E 2 is diffusion-based. I'm not going to get into that today. This is already a long enough video. But anyway, if you're interested in that stuff, that's the kind of architectural differences between the two. But now we've got Dall-E 2, which is even better outgrowth. So we've got that from OpenAI. And competing with that from Google, we've got Imagen, which I found out is actually pronounced Imagen. I thought it was actually Imagen because it's spelled I-M-A-G-E-N. So I thought it was Imagen, but it's actually Imagen. Anyway, that's got about 2 billion parameters. That's from Google. Like I said, it kind of competes with Dall-E, Dall-E 2. And then the latest from Google is Parti, which stands for Pathways Autoregressive Text to Image. That has 20 billion parameters, and as it says in the name, it's based on autoregression. So anyway, you can see how diffusion and autoregression are competing with each other. And then from DeepMind, we've actually just recently gotten a project called Gato, which is a multimodal version of this GPT large language / image model. It's designed not to do anything particularly well. These other models are designed to take text and turn them into two-dimensional pictures. That's what they're designed to do, or paintings, or whatever you want. But anyway, Gato is specifically designed to do 600 tasks. They say it does 600 tasks about as well as a human being, from playing games to doing pictures to having conversations, etc., etc. So this is really moving into multimodal stuff where we start thinking about really artificial general intelligence. So cool, we've got all of these amazing things that are popping up, and it's just incredible, and our minds are blown. And we look at these text transcripts and we look at these images and we say, how is it possible that machine learning, just an algorithm, can do this sort of stuff? It is really, really mind-blowing. But when we start looking at something like Gato, we're getting away from things that are specifically trained to do something to more generalized creative things. Now, it's not nearly as successful in each individual task as these more specifically overfit models are, but the idea is that it can do a whole bunch of things decently well, which means it doesn't need to be retrained for every single task it does. So that's a really interesting new option that's coming about. Now, again, I'm not trying to be exhaustive here. There's a ton of other models out there that are doing very, very interesting and cool things. But that's sort of the, the lie of the land at this point, the general idea of what's going on. First of all, how is this going to affect a company like Tesla? Tesla's already clearly using a lot of this stuff in their full self-driving stack. And the advantage this gives them is the ability to, again, create that bird's eye view network. It allows them to go from a bag of points, just a bunch of colored pixels, into something that makes sense. You need to use these sort of transformer type networks to pay attention to things across spatial boundaries and across temporal boundaries and things, and go like, yeah, that's a car, and it's still a car in this frame, and it's still a car in this frame. It's that definition. It's going from just a completely chaotic view of the world to something that makes sense, to like a vector-based object thing where cars and people and streets and lane lines and lights and all of that kind of stuff. Because once you get to that point, you can then act on it. You actually understand the world. So this stuff is critical for what's going on with Tesla right now. And I believe it's what's probably opened up their full self-driving to where Andrej Karpathy and Elon Musk and Ashok Elluswamy and other people think that they're actually probably going to solve level 4 technical capability driving by the end of 2022. So that's the kind of thing that we're talking about right now. But now let's cast ourselves forward just like 4 or 5 years, right? All of this stuff has happened in the last 5 years. We've had an incredible leap. And in terms of this image stuff, that's only happened in the last couple of years. So, maybe we're looking at 2024, 2025. So we might not have to go past the middle of this decade to really start thinking about this. So what kind of things could actually happen based on the development of these things, assuming that this trajectory keeps on going and it doesn't slow down for a while? We could certainly have things like real assistants, right? Actual assistants that can help us instead of stuff like Siri and Alexa right now that are okay. You command it to do something and it does it, and that's really fantastic and I love it. But things that actually help you in your life, like saying like, oh, you probably need to go grocery shopping today, or hey, you haven't balanced your checkbook in a while, or hell, something that maybe becomes a life coach and says like, you've been spending an awful lot of money at restaurants lately, perhaps given your income and the amount of money it costs, maybe it'd be a good idea if you stayed away from restaurants for a while, right? It would be one of those annoying life coach sort of things. But this is the kind of thing that it could do, because if it can take in this kind of data, it can understand well enough to help us do a better job in real life. Certainly, I think it's going to have a massive effect on full self-driving. I've said before, I think what can happen is that full self-driving can become creative like people. Instead of just following rote rules, and again, up until very recently, most of Tesla's full self-driving was actually hard-coded. It was just a bunch of if-then statements. And so if we can move to neural networks and then to transformers and then to creative capabilities within those transformers, the car can start to come up with creative solutions. And when you think about it, most of the time you drive, it's just pretty boring and you do the same thing. But every once in a while, you have a bunch of cars parked in random directions and stuff like that. And you have to figure out how to get out of that situation in a parking lot, or maybe there's an accident on the road and you have to figure out how to get around all this stuff. That requires some degree of creativity. And that creativity, if it can be imbued into a transformer, into full self-driving, that will have a massive effect on the capabilities of Tesla and potentially other full self-driving stacks. So that's a really, really fascinating outcome as well. And it could happen in the next couple of years. And then we can turn to things that we've always thought of as absolutely human, like creativity, like painting and writing and coming up with a script for the next big movie or something. I mean, I think that that's in danger because scripts are very, very formulaic. I have a feeling one of the first real outgrowths of a large generative pre-trained transformer model, a big language model, could be that it could write the next blockbuster Marvel movie, right? You could just give it all of the Marvel universe, just feed it all of that information, and then say, give me scripts, and it could produce 1,000 scripts in an hour, right? So even if each one of them is only kind of garbage, you can go through and maybe one of them is genius. It's like you've got 999 that are just mediocre, and then there's one that's like, oh my gosh, the next Doctor Strange movie is going to be fantastic, and it was written by an AI. So I don't see that as that far away because movies are really, especially especially big blockbuster movies, are very formulaic and don't require that much creativity. So I think that that's a definite outgrowth. I think the art that we're seeing right now is really amazing when you can just type in a text prompt and actually get artwork out of this. And then I think we can actually move into the real world where we can talk about robotics and things like, the Teslabot or other humanoid type robots, or helper bots like dog robots or things like that. But these robots that are capable of being creative and creatively interacting with the world and creative problem solving. So a lot of this stuff that we think of, think about if you have a robot plumber that can come at 3 o'clock in the morning and is not going to be grumpy because you got it out of bed, right? So you have a leak and it's flooding your kitchen or something like that. The robot comes. Plumbing or any of this kind of repair work is relatively creative because you have to figure out what the problem is. You have to crawl back in a really awkward space, and then you have to fix the problem, and you have to do it all under relatively stressful conditions. I would see that a real world robot, if it's creative enough, if its brains are creative enough, could solve these types of problems. So this and many, many other examples, and again, let me know in the comments some other example ideas that you have. But anyway, all of these examples indicate to me that all of the things that we hold dear to being human are going to be suspect. They're going to be potentially replaced by either AI in a machine or AI in the real world in terms of a robot. So that's going to be a really interesting societal change. And then the last piece of this I would just want to touch on really, really quickly is consciousness itself. Human beings, we think of ourselves as very, very special and particular, but one of the things that could come about from these larger and larger and more productive models is that we could realize that we're not that bright, that we're basically just a bunch of inputs and outputs. We're a black box, and if you give us more or less the same inputs, you're going to get more or less the same outputs, and that our idea of creativity is a lot less creative than we actually think it is. It's just synthesizing a bunch of different inputs and coming out with an output in different formats. So we may find out that consciousness is not as special as we think it is. And I don't know what to think about that. I kind of like consciousness being special, but at the same time, I also realize that it's probably just an emergent property of complexity, and that if something gets complex enough, it's probably going to have the form of consciousness. So eventually we really could have a robot or a machine that's able to pass the Turing test, and we really don't know, even if we know it's a computer, we don't know if it's conscious or not, right? It'll say it's conscious and it'll indicate by every means that we can test it that it's conscious. Then how do we say it's not conscious anymore? And then what happens with robot and computer rights? If these things actually have consciousness and they're able to convince us of that, do they have the same rights that humanity has? And that's all fascinating and really kind of mind-blowing to think about as well. All right, so that's a lot of stuff to think about. I know I just kind of slammed it at you. Like I said, I'm considering this the beginning of a conversation, so let's continue the conversation. If you did enjoy this video and it, made you think about a bunch of stuff and maybe made you go like, woo, wow, please do like it so other people can find it, and also consider subscribing for more of this kind of content, and of course, so you can see the next videos as they come out. As always, a huge shout out to my patrons on Patreon. Thank you all so much for your support. A lot of this comes from conversations that we've all had on Discord and other places, so thank you so much for all of that and for inspiring me to do something like this. And of course, if you want to join the team, just check out the link in the description. And if you're interested in a whole bunch of really cool merch, check out our merch store. Link is in the description. We have Teslabot t-shirts, the Tesla meme t-shirt, Success is a Possible Outcome, 4680 battery cells. All of that stuff is on t-shirts, mugs, tumblers, and on. So check it out. And for those of you interested in investing, check out WeBull, an amazing platform for buying and selling stocks, and now cryptocurrencies like Bitcoin, Dogecoin, and others. Open an account and get a free stock valued at up to $200, and fund your account and get another free stock valued at up to $1,600. Check out the link in the description and help the channel at the same time. Thank you. And finally, don't forget we are both Tesla and Amazon affiliates. If you look in the description, you can see how going shopping for a solar roof, a power wall, or anything on Amazon helps out the channel. In the meantime, I'll see you in the next one. Bye-bye.